Alright guys, in this video we'll be looking at how to find the slope, and there's three different methods that we can use in order to find the slope, and that's all going to depend on what we're given. The first thing we're going to look at is when we're given an equation, more specifically an equation in the form y equals mx plus b. Now this form is called the slope-intercept form, and the reason they call this the slope-intercept form is because that m is going to represent our slope and that letter b is going to represent our y-intercept. So anytime we have an equation written in this form, y equals mx plus b, and we're asked to find the slope, all we're going to do is look for the value in front of our x. Now that's going to be our slope. So I've got 6 examples here that we're going to look at, and all we're going to do is find the slope. Notice every single one of these equations is written in that form, y equals mx plus b, or what we call the slope-intercept form. So here we go. First one, y equals 2x plus 3. What we're looking for is the slope, which means we're looking for the number in front of the x, which in this case is 2. Therefore our slope is 2. And again, I'm going to use the letter m to represent slope. So the slope is 2. Number 2, we have y equals negative 5x minus 2. The slope for this equation is right here. Therefore our slope is negative 5. Number 3, we have the equation y equals 1/2 x plus 4. What I'm looking for is the slope, and the slope is going to be m equals 1/2. Again, it's the number in front of the x. Let's keep going. Number 4, y equals 3x minus 4. The slope on this equation is going to be 3. It's the number in front of the x. Number 5, we got y equals negative 2x plus 6. Again, I'm looking for the slope. The number in front of the x on this equation is negative 2. And finally, number 6 here, the slope on this equation is 6. It's the number in front of the x. So this is how we find the slope if we're given the equation in the form y equals mx plus b, or what we call the slope-intercept form. Alright, we're going to continue looking at how to find the slope. In the first 6 examples I gave you, we looked at how to find the slope given an equation. Now we're going to look at how to find the slope given a line. So what I have here is a line, and what I want to do is find the slope of this line. Now remember, when I refer to slope, slope is simply the rate of change, or the rise over the run. Rise over run. So what we're going to do is find the rise over the run for this line. So in order to do that, what I'm going to need to do is find 2 points on this line. Now the 2 points you choose is your choice. However, you want to make sure that these are ordered pairs that we can read fairly simply. So I'm going to use these 2 points. I'm going to use the ordered pair 0, 2, and I'm also going to use the ordered pair 2, 4. So what I'm looking for is the slope, or the rise over the run. So what I'm going to need to do first is figure out how much it takes to get from one point to the other. How much do I have to rise? Well, as you can see from here, first I have to go up 1 unit. That's my rise, 1. Then I'm going to have to run over twice. Therefore my run is 2. So the slope of this line is 1 over 2, or 1/2. Okay. Now, what if I didn't choose those 2 points? What if I had chosen this point here and maybe this point over here? Well, notice here, if I want to get from one point to the other, in this case I have to rise 1, 2, 3, 4 units. Then I have to run 1, 2, 3, 4, 5, 6, 7, 8 units. So I've got the slope of 4 over 8. However, since this is a fraction, notice what happens when I reduce 4 over 8. 4 over 8 reduces to 1/2. So I still end up with the same slope. So the 2 points you choose really shouldn't matter. We should still come up with the same slope after reducing our fractions. Alright, let's take a look at another example. Here's the next line we're going to look at. Again, what I'm looking for is the slope, or the rate of change, rise over the run. So the first thing I'm going to do is choose 2 points on my line. I'm going to go ahead and choose this point right here, and I'll choose this point over here as well. Notice that these 2 points that I've chosen are on the line. So what I'm going to need to do now is find my rise over run. How much does it take to get from one point to the other? So what I'm going to do is I'm going to start with the point over here on the left. So what I'm going to need to do is I'm going to need to go down 2. Now because I'm going down, rather than using a positive number, I'm going to use a negative number. So I'm going down 2. So I'm going to use a negative 2. Oops. So I'm going to use a negative 2 to represent that going down 2. Now I'm going to have to figure out how much I might run. So notice I'm going to have to run 1, 2, 3 units. Therefore my slope for this line is negative 2 over 3. I went down 2 and over 3. But again, what if I didn't choose those 2 points? What if I had chosen some other points, such as maybe this point here and this point over here? Alright, let's take a look. Remember, we should end up with the same slope. In this case, I have to go down 1, 2, 3, 4 units. So again, negative to represent that I'm going down 4. And then I'm having to go over 1, 2, 3, 4, 5, 6 units. So the slope here is negative 4 over 6. But again, if I reduce that, I end up with a negative 2/3. Same thing that I got from the previous 2 points. So once again, the 2 points you choose shouldn't matter as long as they're on the line and you reduce your fractions. We should end up with the same slope. Alright, the next line we're going to look at is this horizontal line. Once again, we're going to find the slope, the rise over the run. So what I'm going to need to do is choose 2 points, any 2 points that are on this line. Now I'm going to choose this point here, and I'll also maybe choose this point over here. Alright, so I want to get from one point to the other. So the first thing I need to do is figure out how much I'm going to go up or down. Now in this case, because it's a horizontal line, notice that I'm not going up or down any. So the number I use to represent not going up or down is 0. We're not going up or down. But I am having to run. I'm having to move over 1, 2, 3, 4, 5 units. So I've got 0 over 5. Well, remember guys, this is a fraction. So when you reduce 0 over 5, 0 divided by 5 is simply a 0. So the slope of this line is 0. Now here's a little hint. Anytime you see a horizontal line, the slope is always going to be 0. So if I had another horizontal line down here, that slope would also be 0. If I had a horizontal line down here, well, guess what? That slope would also be 0. The slope of any horizontal line is always going to be a 0, and that's because we're not moving up or down any. Next thing we're going to look at is a vertical line. We're going to find the slope of this vertical line. So the first thing I need to do is choose 2 points on this line. So I'll go ahead and choose maybe this point here and a point down here. Alright, so the first thing I'm going to need to do is figure out my rise. How much I'm going to go up. So if I start at this point down at the bottom, I need to rise 1, 2, 3, 4, 5 units. Then I'm going to need to run. Notice I'm not moving left or right any in this particular case, and the number I use for that is 0. So I'm not moving left or right, so I'm using 0 for my run. Now notice, this is a fraction, and because we have 0 in the denominator, we call this undefined. Okay? So anytime we have 0 in a fraction down in the denominator, we say that it's undefined, and we call this slope for this vertical line undefined as well. Now, here's a little secret. This vertical line here would also be undefined. If I had a vertical line over here, well, that slope would also be undefined. So anytime I have a vertical line, the slope will always be undefined. Alright, we're going to look at one last thing here. I've got a line again, and what I want to do is find the slope, the rise over the run. Well, as I've already shown you, we can find the slope by finding 2 points, which I've done here. I found 2 points. I'm using the ordered pair 0, -2. That's one of the points. And I've also got the point 4, 6. So if I wanted to find my rise, I would need to go up 1, 2, 3, 4, 5, 6, 7, 8 units. Rise 8. Then I would need to run 1, 2, 3, 4. 4 units. But again, since this is a fraction, I need to reduce it. 8 over 4, or 8 divided by 4, would simply be a 2, or 2 over 1. That's the slope of this line. Now, the truth is, we don't even need the graph. We can simply just use the 2 points. So what I'm going to do is I'm going to strip away everything except for these 2 points. Alright? So all I've got are these 2 points. I'm going to go ahead and write those 2 points down. 4, 6, and 0, negative 2. And what I'm going to do is I'm going to show you that we can find the same slope of 2 over 1 simply using the 2 points without having to look at the graph. Alright, so what we're going to do is we're going to use a little formula. And that formula is y2 minus y1 over x2 minus x1. This is how we're going to find the slope given 2 points. Now, you say, what is y2, what is y1, what is x2, what is x1? All that simply means is the first x, first y, second x, second y. So what I'm going to do is call this my first order pair, and I'm going to call this one over here my second order pair. So what I'm going to do is I'm going to take the second y value, which in our case is going to be the negative 2. I'm going to subtract the first y value, which in our case is going to be the 6. Then I'm going to do the same thing with the x's down at the bottom. So our second x is 0. I'm going to subtract from that the first x, and our first x is a 4. So watch what happens here. Negative 2 minus 6. Negative 2 minus 6 is equal to a negative 8. If I subtract 0 minus 4, 0 minus 4 is a negative 4. So I've got negative 8 divided by negative 4, which if I reduce that, negative 8 divided by negative 4 turns out to be a positive 2, or 2 over 1, which is exactly what I have right here. So once again, I don't necessarily need to look at the graph. All I need is at least the 2 points in order to use this equation right here. So let's try a couple more. Alright, here's another 2 points, 3, 4, and 2, 1. We want to find the slope, or the rise over the run. So once again, I'm going to call 3, 4 my first ordered pair. I'm going to call 2, 1 my second ordered pair. So what I'm going to do is I'm going to start by subtracting the y's. Take the second y, which is a 1. Subtract the first y, which is a 4. Do the same thing with your x's. Take your second x, and that's a 2. Subtract your first x, that's a 3. So 1 minus 4 would give us a negative 3. 2 minus 3. 2 minus 3 would be a negative 1. But after reducing or simplifying this, negative 3 divided by negative 1 turns out to be a positive 3. So the slope of these 2 points would be 3.